Well, today we have a Wells Gardner 25-inch K7400 on the bench, and this was sent in to me as a trade. So I already had a working K7400, rebuilt everything, and the person that owned this wanted a replacement. So we struck a deal to where I would send this person an already rebuilt one, and they would send theirs in to me as an exchange, plus a little money, to cover cost of repairing this one. So that's what we have here, and it turns out that this one actually has a shorted HOT. So I'm going to actually turn this on, and you can hear what it's doing, and I'll tell you the difference between knowing if you have a bad power supply problem or an HOT problem, because there's different levels of ticking. So this one's going tick, 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 tick. That's indicative of a shorted HOT. Now if you hear tick, 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 that's indicative of a bad power supply problem, or power supply section problem, or bad U101, or whatever you want to refer to it as. But so fast ticking, tick, 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 tick is HOT. Slow ticking, tick, tick, tick is power supply. So let me turn this on. You can hear what it's doing here. 1, 2, 3. Okay, off it is. So tick, 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 tick. We got a bad HOT. So let's get this off of the tube and go over everything and see if we can figure out what's happening here. Okay, so here it is off the tube, and we're ready to start troubleshooting. I got my fan here running. If it's a bit noisy, and I apologize. But so what causes an HOT to short out on the K7400? Now, I will say that the methods I'm going to use here are the same for a K7400 or a K7500. The U2000 and the U5000 have different methods. Like for instance, there's R760 and R765 is not populated on the 7400 and 7500, but it is populated on 2000 5000. So if you have an HOT that's shorted, or shorting, if multiple HOTs are shorting on this series of chassis, you don't have to worry about the R760 or R765 like you would on the 2000 5000, so we can disregard that. So the most common problem, well, I don't say the most common, let's say there's 3 real common issues that cause an HOT to short out. Either it simply just fails. There are 2 film caps here, C119 and C121. Either one of these 2 yellow film caps can fail or short, or it's just simply faulty caps. Now, in my experience, most of the time it's just bad caps. Now, none of these caps actually look bad on the outside, but it's absolutely notorious that this 250 volt, or it's, on this one it's 200, it's original, 200 volt, 100 microfarad cap right here likes to go bad quite often. And as well as this, is this the 33 one? I can't read it. Yeah, 33. So this 250 volt 100 and the 250 volt 33, these 2 caps like to go bad all the time. When those go bad, it takes out the HOT. So you got the HOT simply failing, you got bad caps, and you have either C121 or C119 can short out or go bad too. Those are the 3 most common problems when you have a shorting HOT issue. So what we need to do is first we'll verify with the meter that our HOT is actually shorted. And I'm sorry if I appear to ramble incoherently because it's early in the morning here for me. So we'll go to diode mode and we'll put negative lead on the center pin, and each outer leg should be about 0.45 voltage drop. Nope, 12 ohms. Other lead, 12 ohms. So HOT is absolutely shorted, so we'll have to yank that out of there. And then we'll go ahead and test, after it's out of circuit, we'll test C119, C121, make sure those aren't faulty. If they're not faulty, then it's probably going to come down to a simple issue of the HOT failing over time, or just bad caps. So first thing we'll do is take this out and then put a new one in. Then we'll go ahead and cap it and reflow it and do all the normal rework I do to it after we check these 2 caps, of course. Then we'll go ahead and test it. So I want to get the HOT out first, so let's just do that. All right. Why is that not, I'm not getting, there we go. I wasn't having the correct pressure on there. Is that all free and clear? That is all free and clear. Okay. So we can grab our tweezers and our screwdriver. Hold on to the nut back here, and that was excessively tight on there. Usually it's not that bad, but nope. Alright, I'm going to free up. I'm going to take all this stuff off of here just to free us up a bit. Remote board off. Neck board. Off. Okay, that's better. So let's get this out of here now. That boy is stuck to the. That is stuck to the heatsink like I've never seen. There we go. Jeez. Wow. I'll probably replace this thermal insulator here. It looks okay. Of course, you want to make sure you check it out of circuit because there could be something on the chassis that's making it read shorted. But yep, 14 ohms. You can't see it there. We'll go to ohms here. 15 ohms and 24 ohms. So she's a goner. Let's check the traces here just to make sure. We're just checking to see that they're not shorted anymore, and they won't be. Yeah, 4.2K, and we're not worried about what they read, just that they're not shorted. So 2.6 megohm. All right. Now, I'm gonna trim these legs off here. These are a bit long. A bit long, okay. Well, let's replace that with a FJL 6920, which is a much more robust and better rated HOT than what was on here from the factory, the C3686 that was there originally. We're going to put in an FJL 6920, 6920. These things, if this thing shorts out on you, then you really got problems. That's all I'm going to say. Alright, let's take the leg here and bend it out, bend it back. There you go, quick and easy. And I'll put this in there, and I know I said I was going to replace this thermal pad, but it looks okay. So I'll just reuse it. It's not a big deal. Line this up, and there we go. Make sure that's equal on there. Yep. Okay. Doesn't need to be that tight, just make it nice and snug, that's all you need. So there's the HOT replaced. Let's go ahead and solder it in. The very next day, oh, the cat came back. Thought he was a goner, but the cat came back the very next day. Lambert. Do 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 do. Okay, with that replaced, let's check and see what it reads. Again, it should read. It's still hot from soldering, but it should read somewhere around 0.43 if I recall. We'll see here. Oh, hang on. There we go. .423 and .423, 4. Yep, so that's good. And it probably could just work right off the bat, but I'm not going to do that because we got to do the cap kit. And I do want to check to see if C121 and C119 read shorted. So if we go just to continuity mode, is all we're worried about. C119 is this film cap, C121 is this film cap, and that relates to these pads here. He says so that's these two pads here, okay, not shorted. And it's always so difficult to find these on the back side. Right here, so these two pads here, not shorted, and these two pads here, not shorted. You get the beep because it's reading through other components, but we're not shorted there, and we're not shorted here. So those two caps, at least on paper or on meter, are not shorted or bad. So with that being done, let's go ahead and remove the L100 here out of the board and do our light bulb test and verify our power supply section is working. Now, there's really not any reason to do that until we at least cap it, but I just want to see preemptively if there is a problem. That way, if it works afterward, we'll know for sure it was bad caps. Because it could just be an issue of the HOT, like I said. Of the three causes, you got the HOT simply just fails over time. It could just be that. It's not always bad caps or some other cause. Sometimes they just fail on their own. But just to see if this works, let's remove the L100 here. And by removing this inductor, this leg of the inductor out of the circuit, we've isolated the output of the power supply right there. It's out of the circuit. With that out of the circuit, the power supply section here is no longer in connection with the rest of the board. So we're only testing this portion here. So we can grab our light bulb, 60 watt incandescent light bulb, which is roughly a good analog for the CRT load on this when it's hooked up to a CRT, and we'll connect one leg to ground, other leg to the output of L100. Pardon me. And when we turn this on, we should get the light bulb to light up. That's all you have to do to verify your power supply is good. But let me check R104 first, because if R104 here reads, some kind of crazy number, then you got something bad in your power supply. One of the quickest and easiest ways to make sure preemptively that your power supply should be good is just check R104. If it reads 10K ohm, around there, 10K to 13K, I've seen it usually, then it's a good bet your power supply is going to be fine. But if this reads some crazy number, then there's going to be something else wrong in the power supply. So let's just see what it reads offhand here. 9.52K. So I am 99.999% sure that this should work as soon as we turn the switch on. So let's go ahead and do that. 1, 2, 3. There you go. And we should be somewhere around 117 volts. Actually, probably more like 118.5 if I was going to guess. So again, meter in volts DC, negative on the frame here for the vertical IC will go to the output, well, the input of L100 here, but 121, that's too high. It should be around 118.5. What that means is that if this was hooked up to the tube right now operating, our B plus would be around 119, and that's too high. So we're going to try to adjust this. And as this, you see here, this is covered in goop, factory glue, this B plus pot. So the easiest way is to get yourself some nice flush cutters here, flush cuts, and chip away from the top. Like, don't try to clip the glue off from the side. Clip it off from the top, and it'll break the glue without breaking the pot. So if we come to the top here and just kind of go like this, there you go. See how easy that was? That's not always that easy. It doesn't always work out that way, but that was a good, successful removal of glue without breaking the pot. So now you want to free it up a little bit more, and look at that. All that glue's gone, all of it. 2 clips there, 2 snips done. So now we need to take some contact cleaner here and spray some contact cleaner on here. And then we'll go back and forth and wipe this pot a bunch of times. clean up those contacts and those carbon traces, put it back roughly where it was, and let's fire this up again and make some adjustments here. Okay, 1, 2, 3. All right, and we are reading 120.8, which you can't see. Sorry about that. 120.8. So I'm going to get a alligator clip here for the ground, for the lead on the meter. Clip that on there. So now I can hold this on the L100 here, and I want to adjust this to about 118.5. So that will equate to 117.5-ish, or closer to 117 when the actual CRT is connected. So if we turn this down to about 118.5 or so, it's awful touchy. We'll go with 118.5. There we go. So now that'll be closer to 117, because B plus should be 117 in normal operation. So yeah, all right, I think that's good. I'm going to get this L100 reinstalled in the board, because I always forget to put it back in. And by always, I mean always. So if I don't do it right now, I'm going to forget later. You wouldn't believe the number of times I've done this, and then go hook this up, and I'm like, it's dead? Why is it dead? I just used it. Well, that's because I forgot to put L100 back in the board. So don't be like me. And put it in before you forget. Like Mike. If I could be like Mike, I wanna be like Mike. Like Mike. All right, well, I think the only thing left to do now is just do a cap kit and a reflow, and we'll give it a try. The neck board's in pretty decent shape. All of the transistors are in somewhat good condition. They're not flopping around. They're not all that loose, so we don't have to worry about too much neck board rebuild. It looks like a relatively low hour 7400, but we'll go ahead and reflow this and get it all looking nice and good too. Get rid of that, and just to see what's going on here, let's get rid of this cardboard backing and take a look here. Yeah, not bad at all. No hideous, I mean, it's not very discolored, no hideous rework. Yeah, not a very high hour 7400 here we have on our hands, so that's good. This is smashed down. This resistor shouldn't be smashed down like that. There we go, a little better. Okay, well, let me show you. I'm not going to do the whole cap kit on camera. I will do a couple of caps here just so you can see my method. I've got a video on a G07 that I'll link down below that I did the entire cap kit in real time, and you can see what I do with that. But we need to reflow the video input header pins. We need to reflow all of the header pins for the neck board interconnect, all the header pins for the remote board adjustment board interconnect, the solder joints here for the vertical position transistor. This transistor here is responsible for your vertical position adjustment. If you have no vertical position adjustment at all, you turn the pot, it does nothing, and it's not the pot on the remote board or the wire harness or the solder joint on the connections here. It's almost guaranteed that the transistor here is bad or it's broken, because there's nothing here to keep it from moving, and over time those solder joints and pads break off from people reworking this or vibration or whatever. So, but those seem to be intact, but we have to reflow those. We need to, you know, R104 is okay, but I like to reflow the entire power supply, all of it, and then go through after the power supply. And the most important places to hit are after the whole power supply. You want to hit the main AC input header pin, because those get super thin and crack, especially when it's in a machine and the connector has constant pressure on it and it's being pulled on. These like to crack. So these here, the video input header pins, the neck board interconnect header pins, the remote board interconnect header pins, the power supply, and the linearity coil, the width coil. Basically, just go look around anything and everything that looks like it might need reflowed and reflow it. But those are the key points on these that you like to hit, or need to hit, or I like to hit, or however you want to refer to. So yeah, let me show you here. I'll take out the 250 volt 100 and the 250 volt 33. I refer to those as that's what's going back in there. These are actually 200 volt, but what I do is I'll hold on to the cap with my fingers and I'll just rock it out. So let's see, right here. So I'll heat up one pad and just move it to the side. I'll zoom in actually here. So I heat up one trace here and just kind of bend the cap over. Then we'll heat up the other trace. And it comes right out. It's just that simple and easy. Now we'll do the other one, the 33. So if I do this one and rock the cap that way, it should just simply, boop, there you go. Now we'll do the same thing. You see here that it's leaning over like that. Now we'll do the same thing to the other pad. And boom, it's out. You know, that's faster, quicker, and easier than using the desoldering guns and the desoldering pumps and all that. Then you can just come back with your braid. Now, if you want to use a pump or a gun or whatever you want, that's totally fine and up to you. But you can see here that this hole's already open. I don't even have to use any braid on that one. So that one's open, that one's open. I mean, you want to touch it up a little bit, but right now I can fit a brand new cap in here and there without even having to desolder what's left there. So I can technically just go like this and hit this one, and then hit this one, and there you go. That's, I mean, it's ready for 2 new caps. Also go ahead and do this and that, but so that's my method. I just go through, repeat that for all the caps on the board. Some of them are a little bit more finicky than others. Like, you really can't do that with the 22 microfarad one down in here because you can't get your fingers in there. So I will use the traditional method. Easy for me to say. I'll use the traditional method and just use the braid to remove the solder and then pull the cap off. But for the ones that you can get your fingers on, rock it out, done. It's that easy. So that's what I do. So I'm going to go through and do a full cap kit, reflow all the points that I mentioned before, and then we'll hook it back up and give it a try. Now, I guess I should go ahead and mention that we want to check our shutdown pot as well. So let's get the glue off of the shutdown pot, because the shutdown pot needs to be adjusted properly as well. And it should be 0.1 volts DC. There's a little test point here, TP201, right there. And you should have 0.1 volts DC on that test point. And if it's not, you got to adjust your shutdown pot. So again, I need to go from the top here and just kind of, there you go, it's gone. And go to the side here. Let's see if I can actually turn it the way that it is. Yep, there you go. Another successful de-gluing without any broken pots. So again, I'll just spray this one down. I'm not sure how much help this does because the carbon pads aren't exposed, but if anything, it's going to help a little bit. But okay, now I'll put it roughly about there. It should be about 75% all the way up or clockwise for it to be in the right position. So if you have one of these that's in constant shutdown, or it fires up and works for a few minutes and then shuts down, you turn it off and it turns right back on again, and you can't figure out why it's shutting down on you, you need to adjust your, or verify at least that your shutdown voltage is correct. So we'll show that here as well. But for the meantime, I'm going to cut away here. When I come back, I'll have this completely reflowed, full cap kit, ready for testing on a tube. So I may just cut back and have it, when I come back, I'll have it on the tube ready to test. So yeah, I think that's what we're going to do. Because it'll be nice for once in a long while to have a video that's not an hour and a half long. So, you know, I did a general inspection earlier, made sure there wasn't missing components or stuff that was going to cause problems, and everything looked okay. Everything looked all right. So, yeah, all right. So I'm going to cut away, come back, have this all done and on the tube ready for testing. And there's not much else that's going to be shown because there's no rework that needs done on the neck board. We'll just reflow what's there. Nothing is demolished or crazy or overheated, and everything's spaced right. Nothing's loose. So not going to be much to do with the neck board here. I do want to preemptively wipe these back and forth. These pots are notorious for being scratchy, so we'll turn them up to about 25%. These series of chassis don't like the drive pots to be up more than about 25%. Anything more than about 25%, the colors like to bleed on you, so we just wipe the pots back and forth, back and forth, back and forth, and then turn it all the way down and up about 25%. So the actual drive pots, I'm sorry, the drive pots you want about 50%, and then the bias pots you want about 25. So it should look something like this when you're done. See how these are all about 25%. If I turn this completely off like that, then up to about 25%, that's about, anything over that, the colors like to start bleeding on you. So we'll just leave it right there. So that'll be our baseline. Any other chassis, you just put them all at half, 50%, and go from there to adjust. But all right, so again, like I've said a dozen times already, I'll do all the rework, come back, we'll have it on the picture tube, and we'll turn it on and see what happens. I forgot one more thing. I had mentioned that if you have a chassis that works for a little bit and shuts off, you turn it on, it comes right back on and everything, and you need to adjust the shutdown pot. But there's another factor here that I forgot to mention that can cause the exact same issue, and that's the sockets here on your power input pins. So power input connection. So these sockets, when you connect the power to it, sometimes when you hook this up and over time and gravity inside a machine, the harness will pull on here, and that will break the solder joints, but also it has a twofold effect where not only it breaks the solder joints, but it causes these sockets to get opened up, and they make bad pin retention on the pin into the socket. So what you do is I'll get a little, this is my, set of tweezers from the iFixit deal. I like to put this down in there and squeeze those sockets back closed a bit so they make better pin retention on the pin, or better pin tension I should say. So you put that in there like that, and you just squeeze the sockets closed a bit more. And that will ensure that if you have a chassis that's randomly turning off and everything, that it's not an issue with the connection. So those are kind of, let's see if I can show you that. So I kind of went a little overboard. They're a little, not too bad. But when we hook this up with the power connector, the pins will reform the sockets. You can kind of see that one's a little bit haywire there. And if we plug this in, you'll get nice good, oh yeah, nice solid pin tension. Take it back out, and it's round again for the most part. So I wanted to point that out because don't overlook that. I forgot to mention that before I cut away. So all right, so now when I come back, I'll have all this ready to go on the tube. We'll see what happens. All right, so everything is done. We got a full recap, a full reflow. Everything is good. Neck board all cleaned up, and main chassis cleaned up, and everything that I discussed a few moments ago from your perspective is now accomplished. So I actually have the meter hooked up as well to the B+ test point, which is right there in front of that cap. We should be seeing around 117 volts if it turns on and works. I haven't tested it yet. And then if we get everything dialed in and working, then we'll adjust our shutdown pot as well. And I have my trusty Mortal Kombat 2 PCB here on the bench we'll use for video input, and everything is connected and ready to go. So let's see if it turns on at all. If any caps explode or if anything like that, let's just see what happens here. 1, 2, 3. It turns on. B+ is 118. Well, that's interesting. But yes! We are extremely out of focus. B+ is 119. Let me adjust this down to 117. Oh, we're too far. 117. We'll go with 117.5. Close enough. And we really need to adjust our focus. But let's go ahead, now that we're working here, 117.4, good to go. Let's move our lead to this test point here for our shutdown pot. And we're looking for 0.1, and we're at 0.0. So we got to turn this clockwise. This pot here will turn clockwise to get to 0.1. Too far. It's very sensitive. Uh, 0.125. Oh, come on. 0.110. Fantastic. 0.1. And it changes along with, like the B+ changes depending on what's on the screen. But 0.1 is what you want. Good to go. So shutdown pot adjusted, B+ adjusted. We have an image. Let's go ahead and set the camera up here. And let's do some adjustments, get this thing looking good. So, all right. Yeah, I don't know if it was just simply an HOT that died due to age or some other unknown influence or bad caps. None of the caps were leaking, none of them were bulging, nothing was visually wrong with the caps. So all I can go off of is that I think the HOT just simply died from being used. I can't say. That's definitely one of the normal regular possibilities. So let's adjust our focus here. If I can get the screwdriver on it. Okay. And let's make sure that it... Beautiful. Okay. That's good. Let's turn our brightness all the way down, contrast all the way down. That's pretty good with our screen voltage. I'm not sure why it was flickering there. Oh, hang on. What's going on there? I'm pushing, if I press on the flyback itself. Oh, our flyback is leaking high voltage because if I just tap on it, see this? I'm just taking the screwdriver and tapping on the flyback case. And if I'm, yeah, something, maybe I can, yeah, it's making a ticking noise too. That's weird. Maybe it just needed adjusting. Let's turn it down roughly there. Does it still do that? Yeah, there's something. I reflowed the whole thing, so it could be a solder joint, but I don't think so. Because I press on the case and it gets super bright like this. I let go of the case and it goes back to dim. No, it's... Actually, you know what? Hang on a second. Let me turn this up. Yeah, I gotta turn that up a little more. It's not leaking high voltage. What it is I think I'm not using the correct. This is a K7000 frame and chassis, or frame and setup and everything. And it's possible that we have a leg. There's a leg on the bottom of the chassis that's very close to touching the metal, and it might be that issue. So what I'm going to do is I'm going to get something for that chassis to sit on and isolate it from the frame. I'll turn this off. I'm going to take a magazine here and just set this between the chassis and the frame. And there we go. Let's turn it back on. Now let's try that again here. Alright, so I'm going to press on the flyback case. Nope, it's not that. So there's either a bad solder joint or something with that flyback. That's unfortunate. Yeah, here, I'll show you what I'm doing here. You can see all I'm doing is just pressing. I'm just going like this and pressing on it. We'll see what it's doing here. Something is, I'll have to take this back off and see if maybe I overlooked a solder joint, or maybe there's a trace that's cracked or something. But let me do that real quick and come back and we'll see if that has been resolved and kind of proceed from there. Okay, so I did not miss anything. It turns out that the reason that the screen is going a lot brighter and intermittently when I tap on the case of the flyback is because the screen pot is faulty. Because I can tap on the screen pot and it does something very similar. See, I'm just wiggling. All I'm doing is taking the screen pot with my finger and just wiggling it, and it's going crazy. So it turns out the flyback is at fault here, because if I just, yeah, it's the flyback. Oh yeah, so see this? Yeah, it's the screen pot on the flyback. Well, that's unfortunate. I mean, I got some, but you know, I'd like to reuse the original. But so yeah, let me just show you an example here. If I was to just simply pull, let's pull this 7000 one out of here. I gotta use 7000. So all I'm doing is just, let's turn a light on here. I'm just wiggling I'm just wiggling like this. I'm just going like this on the screen pot. And just the act of doing that makes this thing, see this? Right now I'm holding all I'm doing is holding pressure on the screen pot. And it's just full bright. If I let go of the screen pot, oh. Yeah, so unfortunately I'm gonna have to change the flyback out. So let's get that done and see what happens after that. Alright, so brand new flyback installed. Here is the original. And absolutely this was the cause of our flashing white screen, because I moved the screen pot around and flash white, go bright white, all that we saw just a moment ago. New flyback is in, and with the new flyback in, I haven't really made any adjustments except for a little brightness and screen and focus and whatnot. But if I tap on this one, nothing. If I move it around, wiggle it, press on it, all jazz, no problem. So definitely the flyback was the cause. We had a sketchy screen pot. That's unfortunate, but that's how it goes. So new flyback's installed, everything's working again. So now let's go ahead and adjust some, let's see, H position. Let's bring up the menu. Well, no, I don't have a controller plugged in. I can't do that. I was going to bring up the menu and go to the crosshatch pattern and adjust our horizontal position and size and stuff, but we'll put it right there roughly. Let's check our width. Oh yeah, width is good. Vertical size is good. Vertical position is good. We'll go roughly there. Go back to the height and each position a little bit again. This way. Well, what do you think? I say that we're good. So, we had a faulty flyback with a bad screen pot. That's going to go right in the garbage. There it goes. And then we had a bad HOT. Whether it was caused by just failure over time or bad caps, I don't know. But I think I'm going to lean towards the fact of it just failing after usage over time, because, like I say, I didn't see any bad caps visually. I didn't check them all either. So, but usually, you know, there weren't any leaking, there weren't any bulging. I think probably we just had a HOT that died. So there you go. So if you have one of these that's ticking, you'll know whether or not it's a horizontal output side of things or a power supply side of things by how fast it ticks. And you'll know what to look for, what to check, what to expect, what to reflow, what to look at. All that stuff. This should be a fairly good tutorial for checking these out when you have the ticking or shorted HOT. So thank you very much for watching. Hopefully you learned something. Like, share, and subscribe. Make sure you comment down below if you have something to say. I appreciate it. And we will see you next time.